Okay, so now we did this question using equations of motion, right? Now what we'll do is we'll try to solve the same question, but this time using the concepts of work, energy, and theorem. Before we start, see, this is going to be a long solution. It is therefore going to be time consuming and would be a bit complex. When I say complex, I mean that this is not purely based on work, energy, and power. It will include concepts from equations of motion, work, energy theorem as well. Okay, right. So visualization first. So we have initial condition and the final condition where the bus is starting at 20 meter per second and at rest respectively. The distance traveled is s. So before we go into work energy theorem, let us first try to understand the basics of how to choose work energy theorem or law of conservation of mechanical energy. So if the system under consideration has the presence of conservative forces alone, then we apply law of conservation of mechanical energy. If there are any forces which are non-conservative in nature, we use the work energy theorem. Braking force or retarding force being one example of non-conservative force. Okay. So one more time. So if the system has conservative forces alone, we go for law of conservation of energy. If there are any non-conservative forces, we make use of work energy theorem, wherein work done is calculated and is equated to the change in kinetic energy when work done is considered by all forces. Okay. Now, what is work energy theorem? It says that the net work done, when we say net work done, it means work done by all forces, right? Work done by all forces is equal to change in kinetic energy, being kinetic energy final minus kinetic energy initial. So this phrase is really important. Work done by all the forces. Okay. Now, for a bullet penetrating its target, the resistive force. Okay, my bad. That should actually come from the previous question. We don't need this here. This is not bullet penetrating a target. This is actually a bus coming to a stop, right? So instead of resistive force, what we have here is the braking force. Okay, and the rest of the explanation remains the same. Now, in this case, we have work done by total forces is equal to change in kinetic energy. Now we assume that for this braking, right, for this velocity to come down, no other force is acting in picture. No other force is acting, which means there is negligible air resistance, there is negligible friction, right? All other forces are considered to be zero. So the only force which is acting on this bus now is the force of brake or the braking force. So total forces can be replaced by braking force. And what is work done by the braking force? It will be equal to force of the braking force into displacement, which is equal to change in kinetic energy final minus kinetic energy initial. Okay. Now, if we evaluate the two conditions, what is initial and final condition? Initial condition being velocity be 20 meter per second, and final condition the velocity being zero, the bus coming to rest. Therefore, half m vf square will be 0 square, vi square would be 20 square, which gives us further, okay, which gives us further that 0 square minus 20 square being 0 square minus 400. Force acting on the braking force can be written as mass into acceleration of the bus. Acceleration of the bus we have found out to be minus 5, which comes from this derivation over here, right? So this is what I said, that some portions of the solution will definitely make use of what? Equations of motion. So we have here v is equal to u plus 80. Time is given to be 4 seconds, and therefore acceleration is equal to minus 5. Now, if we have acceleration is equal to minus 5, come back to this derivation again from over here. What we get is m into minus 5 into s is equal to half into m into minus 400, right? Now, from this, what is s is equal to? Minus, let me do the cancellation here. So we have negative by negative is positive, right? So numerator, 5 on numerator becomes 5 on denominator. 2 into 5 is 10. Negative by negative is positive. 400 by 10 is 40 meters. Therefore, the correct option would be the distance traveled by the bus would be S is equal to 40 meters. And if you have any doubt in this, finding the value of A again, let me just write it for you one more time. So we have velocity, final velocity is equal to 0. Initial velocity equal to 20 meter per second, which is 72 kilometer per hour. Time is 4 seconds, given to us that brought to halt in 4 seconds. So we have 20 plus 4A, therefore A is equal to minus 20 by 4, which is equal to minus 5. Okay, so we just try to include both equations of motion and the concept of work energy power. All right, so that's it with this question over here. I'll just leave on this calculation for you to make a note of this. Okay.